Magnesium oxide. Let's find the percentage by mass of magnesium in magnesium oxide. So this section is percentage mass of elements in a compound. Okay, so magnesium, what do? I take the relative molecular mass of the element I'm looking for, and I divide it by the relative molecular mass of the compound that it's in. And of course, for percentage, I multiply by 100. Okay, so let's have a look at magnesium. Magnesium. What's the relative molecular mass of the element? You go to the periodic table, it's 24. I'm dividing that by the relative molecular mass of magnesium oxide, which is 24 plus oxygen is 16. So that gives me 24 over 40, and then I just work that out and multiply by 100. So 24 divided by 40, multiplied by 100, that gives me 60. So 60% of magnesium oxide is magnesium, which means that, what's the other 40%? Oxygen. Okay, which implies that 40% has to be the oxygen. Okay, that's the first one. Okay, yeah, that's enough. So let's do magnesium sulfate now. So we want to find, I'm going to look for the percentage oxygen in magnesium sulfate. The percentage oxygen. Find the percentage oxygen in magnesium sulfate. So I'm going to take the relative molecular mass of the oxygen and then divide by the relative molecular mass of the compound. And of course then for percentage, I'm going to multiply by 100. Now look at your formula. Your formula is very important. In magnesium sulfate, you've got 4 oxygens. So that means you must take that into account when you're finding the percentage. So the relative molecular mass of oxygen is 16, but you've got 4 of them. So I need to multiply that by 4. And then I divide by the relative molecular mass of the whole thing. So this then is 24 for magnesium, 32 for sulfur, and 4 16ths for the oxygen. And then to get percentage, I multiply by 100. So this will give me 64 over, what's that? 64 plus 32 plus 24 gives me 120. So 64 divided by 120 is 0.53. Repeating. And I multiply by 100, of course, to get percent, and that's 53%. That's it, Leah. Right, we're going to find the percentage of lead, we're going to find the percentage nitrogen, and we're going to find the percentage of oxygen. We're going to do the 3 of them this time. Okay? Right then, so let's find the percentage lead. To get percentage lead, remember, you divide, or take the relative molecular mass of lead, which in this case is 207. So I'm going to take 207 and divide that by the relative molecular mass of the whole thing, which is 207 plus. Okay, so I've got a bracket with 2 outside the bracket. That tells me I've double everything inside the bracket. So nitrogen is 14. I've got 2 of them, so that's going to give me 2 14s. I've got O3 inside the bracket, but I need to double that, so that's 6 oxygens, so that's 6 16ths. So this becomes 207 plus 28 plus 6 16ths gives me altogether 331. And of course, for percentage, I multiply by 100. So 207 divided by 331, and that gives me 62 point, I'll go to 1 decimal place here, 62.5%. Now I'm going to find the amount of nitrogen. So, look at your formula. You've got NO3 twice, which means you've got 2 nitrogens. That 2 outside is important. So I'm going to get the relative molecular mass of the nitrogen, and I've got 2 of them, so that's 2 14s. Divided by, I know what the compound is, it's 331. So I'm going to divide that by 331 and multiply by 100. and that will give me I'll go to 2 decimal places this time, 8.46%. Now I can go through oxygen, or what would be easier to do here, add them and take them from 100, yeah? So I'm going to do 62.5 plus 8.46, and then I'll take that from 100, and that will give me 29.04% oxygen. So in the last bit, it has to be from 100%. Or you could go through the calculation. How many oxygens would you put up here if you were going through the calculation? 6, okay, this would be 6 16s divided by compound 331 and then multiply by 100, and that should give you the same answer anyway.